Hello viewers, in today's session we are going to discuss another important and conceptual problem from functional equations. So here we are going to discuss this important problem in which we are given a function f from R to R, where R is the set of real numbers, and here we are given the equation f of x plus y is equal to f of x f of y, that is the product of f of x and f of y. And this functional equation is valid for all values of x and y belonging to the set of real numbers. And moreover, here we are given that f of x is not equal to 0. Now let us here we are also given that the function f of x is differentiable at x is equal to 0, and the value of the derivative at x is equal to 0, that is f prime of 0, is given as minus half, right? So we are given all these conditions and we have to find out the form of the function, that is f of x. So we have to find the function which satisfies this functional equation. So here we are given the equation f of x plus y is equal to the product of f of x and f of y. Now let us replace x by 0 and y by 0 in this equation. So we have f of 0 plus 0, and here we have f of 0. Here also we have f of 0. Now here 0 plus 0 is 0, and here we have f of 0 square, right? Okay, so now taking f of 0 square to the left hand side, we have f of 0 minus f of 0 square, and this is equal to 0. So now taking f of 0 common, we have 1 minus f of 0, and now we can see that we have the product of two numbers, that is f of 0 and 1 minus f of 0. So we have this factor 1 minus f of 0, right? So from here we can conclude that either f of 0 is equal to 0 or 1 minus f of 0 is equal to 0. So from here we can easily get f of 0 is equal to 1, and from here we have f of 0 is equal to 0. But in the given problem we are given that f of x is not equal to 0 for any x belonging to the set of real numbers, right? So here f of 0 cannot be equal to 0. So here f of 0 cannot be equal to 0 due to this condition. Hence we have to accept f of 0 is equal to 1. So now here we are given that the function f of x is differentiable at x is equal to 0, right? So let us define the derivative of f of x, that is f prime of x is given by the limit, that is limit h tends to 0, f of x plus h minus f of x divided by h, right? So this is the definition of derivative of f of x, and remember here h is infinitesimally very small and h is a positive quantity, right? Okay, so now here we have this term, that is f of x plus h. So let us apply this equation to this term, right? So using this equation we can now write f of x plus h as the product of f of x and f of h, right? So let us substitute this value over here. So now the derivative, it becomes limit h tends to 0. We have here f of x, f of h minus f of x, and here we have h. Now in the denominator we can take f of x common, so we have f of x, and here we have f of h minus 1, and here we have h. Now we can take f of x in front of the limit notation, because f of x is independent of h. So we have f of x limit h tends to 0, and here we have f of h minus 1 divided by h. Now let us consider this limit. So now let us consider this limit. Now in order to get the value of this limit, let us once again come to the definition of the derivative, right? So here we have f prime of x is equal to limit h tends to 0 f of x plus h minus f of x, and here we have h. Now let us replace x by 0. That is, let us find out the derivative of f of x at this point 0, because we are given that the function f of x is differentiable at x is equal to 0. So we have f prime of 0. Here we have limit h tends to 0, and here we have 0 plus h, because we are taking x is equal to 0. So 0 plus h is simply h, and here we have f of 0, and here we have h. Now f prime of 0 is equal to limit h tends to 0. We have f of h minus, now see, f of 0 is equal to 1. So taking this value over here, we have 1, and here we have h. So we can see that the limit h tends to 0, f of h minus 1 over h is equal to the derivative of the function f of x at x is equal to 0. So here we can now write f prime of x is equal to f of x multiplied with f prime of 0. Now f prime of 0 is given as minus half. So taking here minus half, we have f of x multiplied with minus half. So now we have this differential equation, that is f prime of x is equal to minus f of x over 2. So this is a differential equation of order 1 and degree 1. So now to get the value of f of x, we have to solve this differential equation by integrating both sides, right? So here we can rewrite this equation as f prime of x over f of x, and here we have minus half. And now let us integrate both sides with respect to x, and here we have dx, and here we have minus half dx, and c is the constant of integration. Now see, this is a special form in indefinite integrals. When we have in the denominator a function f of x and its derivative, it exists in the numerator, then the integral of f prime of x over f of x is simply given by log of f of x, right? So this is a well-known form in indefinite integral. Whenever we have the integrand in the form that is in the denominator we have f of x, and in the numerator the derivative of f of x it exists, then the integral of this function f prime of x over f of x is log of f of x. Now here we have minus half integral dx plus c, so this is minus half x plus c. So we have arrived at this equation, that is natural log of f of x is equal to minus half x plus c. Now our next aim is to get the value of this constant of integration. So now using the boundary conditions here, we have for x is equal to 0, f of 0 is equal to 1, right? So utilizing this condition over here, we have log of f of 0, taking x is equal to 0, we have minus half times 0 plus c, and this is the natural log of 1, and here this is this term is 0. We have c that is equal to c, and log of 1 is 0, so c is equal to 0, right? So now taking this value of c is equal to 0, over here we have log of f of x is equal to minus half x. So now this equation can also be written as e raised to log of f of x is equal to e raised to minus half x. So taking the exponential of both the sides, we have e raised to natural log of f of x is equal to e raised to minus half x. So this term is simply equal to f of x, because we know that e raised to log of a is equal to a, and here we have e raised to minus x by 2. So viewers, the value of the function f of x is given by this exponential function, that is e raised to minus x by 2.